What if I told you that every black hole in the universe has an expiration date? We've all been taught that black holes are these eternal cosmic monsters that swallow everything and last forever. But that's actually one of the biggest misconceptions in astrophysics. The truth is far more fascinating and terrifying. Every single black hole, from the smallest to the supermassive ones at the center of galaxies, is slowly dying. They're evaporating away, particle by particle, and the clock started ticking the moment they were born. This mind-blowing process is called Hawking radiation, named after the legendary physicist Stephen Hawking, who discovered it back in 1974. Here's how it works. At the very edge of a black hole's event horizon, something incredible happens. Quantum physics tells us that empty space isn't really empty. It's filled with virtual particles constantly popping in and out of existence. Normally, these particle pairs annihilate each other instantly. But when this happens right at the event horizon, one particle can fall into the black hole while the other escapes. The escaping particle carries away energy, which means the black hole loses a tiny bit of mass. This happens constantly, creating a faint glow of radiation around the black hole. Now here's where it gets really interesting. The evaporation rate depends entirely on the black hole's size. Smaller black holes evaporate much faster than larger ones. Let me give you some mind-boggling numbers. A typical stellar black hole, formed from a collapsed star about 3 times the mass of our Sun, would take approximately 10 to the power of 67 years to evaporate completely. That's a 1 followed by 67 zeros, an unimaginably long time. To put that in perspective, the current age of our universe is only about 13.8 billion years. But what about smaller black holes? Primordial black holes, which theoretically could have formed in the early universe, could be evaporating right now. If one with the mass of a small mountain existed, it would be emitting radiation equivalent to a nuclear power plant. And when they finally reach the end of their life, something spectacular happens. As a black hole gets smaller, its evaporation accelerates dramatically. In the final moments, it releases an enormous burst of energy, equivalent to millions of nuclear bombs exploding simultaneously. This final explosion would be one of the most energetic events in the universe. But here's the really wild part. We've never actually observed a black hole evaporating. Why? Because the timescales are so immense that for all practical purposes, most black holes we know about will outlast the stars themselves. Even the supermassive black holes at galactic centers, weighing millions of solar masses, would take timescales longer than the current age of the universe multiplied by trillions. However, this process has profound implications for the ultimate fate of our universe. In the far, far future, when all stars have burned out and galaxies have drifted apart, black hole evaporation might be the last significant events occurring in an otherwise dark and cold cosmos. The evaporation timeline follows a specific mathematical formula discovered by Hawking. The time it takes for a black hole to evaporate is proportional to the cube of its mass. This means if you double the mass of a black hole, it takes 8 times longer to evaporate. That's why the supermassive ones take virtually forever. But what exactly happens when a black hole vanishes? Does it just disappear? The current understanding suggests that when a black hole's mass becomes extremely small, quantum gravity effects become important, and our current theories break down. Some physicists believe information might be released back into the universe, solving the famous black hole information paradox. Others suggest completely new physics might be revealed. The study of black hole evaporation isn't just academic curiosity. It's helping us understand the fundamental nature of reality itself. It represents a beautiful intersection of general relativity and quantum mechanics, 2 pillars of modern physics that don't normally play well together. Hawking's discovery showed us that black holes aren't the eternal prisons we once thought. They're dynamic, evolving objects that follow the same laws of thermodynamics as everything else in the universe. They have temperature, they emit radiation, and yes, they eventually die. So the next time you look up at the night sky and think about those mysterious dark objects lurking in space, remember, they're not permanent. Every single one is counting down to its final moment, slowly fading away in a process that will continue long after humanity is gone, long after our sun has died, and long after our galaxy has merged with others. The cosmic death clock is ticking, and it's been running since the beginning of time itself. Which black hole fact blew your mind the most? Drop your thoughts in the comments and follow for more cosmic revelations.